Have you ever stopped to think about all the invisible forces that are keeping you alive right now? It's pretty wild. There are all these systems working in perfect balance inside you and all around you. Well, today, we're going to pull back the curtain on one of the most important ones, these unsung chemical heroes called buffers. Let's dive in and see how these tiny guardians keep our world and our bodies in perfect harmony.
Okay, so to really get why these things are so critical, you gotta understand that life itself, well, it's basically living on a chemical razor's edge. Seriously, it's this incredibly delicate, constant balancing act.
And here it is. This is the magic number for that balance. The pH of your blood, it has to hover right around 7.4. And look, that's not just a friendly suggestion, it's totally non-negotiable. It's a hard rule for your body's chemistry to even work at all.
So the obvious question is, what happens if that perfect 7.4 starts to drift even a little bit? Well, let me tell you, it is not good. If your blood's pH drops below 7.0 or climbs above 7.8, life itself is in danger. I mean, think about that. That is an incredibly narrow window for survival.
Right? So how on earth does your body stay inside that tiny, safe window? I mean, you eat acidic foods, your muscles produce lactic acid when you work out. What gives? Well, it uses these amazing internal bodyguards. And that is what we're talking about today.
So what exactly is a buffer? Okay, here's the official definition. It's a compound or a mix of compounds that resists changes in pH when you add small amounts of an acid or a base. Basically, they're the guardians of stability. But honestly, an easier way to picture it, just think of a chemical sponge. That's really all it is. When things start to get a little too acidic or a little too basic, this sponge just soaks up the excess. It keeps everything perfectly in balance. It's such a simple idea, but it's incredibly powerful. Now, this is where it gets really cool. How does this chemical sponge actually work? It's not just magic. It's this really elegant two-part system that's designed to handle threats coming from both sides. So, let's take a look at an acidic buffer. It's got two parts, right? First, you have a weak acid, and second, you've got its partner, the sponge part we've been talking about. So let's say a strong, nasty acid shows up. Boom! The sponge partner swoops in and just soaks it right up, neutralizing the threat. But what if a strong base shows up? No problem. The weak acid component steps up to the plate and neutralizes that. It's like this brilliant chemical tag team.
And what's great is that this system works for both types. You've got acidic buffers, like acetic acid, and you've got alkaline or basic buffers like ammonium hydroxide. But here's the key takeaway. The fundamental idea is exactly the same. They both have two parts, they both work together to shut down incoming threats, and they both keep that pH stable. Simple as that.
So, this incredible chemical tag team, it's not just some biological trick happening inside our bodies. Turns out, buffers are absolutely essential in the world all around us, especially when you look at fields like science and medicine. Just take pharmaceuticals, for example. Ever wonder how a life-saving drug stays dissolved and active in an IV bag? Buffers. They're what stop medicines from breaking down on the shelf. And maybe the best example. You know those sting-free eye drops? The only reason they don't burn is because buffers match their pH perfectly to your body's, so they actually soothe your eyes instead of irritating them. Pretty smart, huh? And this just shows you how many different, finely tuned environments our body is juggling all the time. I mean, look at this, your blood and your tears. They actually share the same pH, 7.4. But then you have something like urine, which has a much wider and way more acidic range. Every single one of these fluids has its own dedicated buffer system, working 24/7 to keep it in its perfect zone. All right, so we've established how vital these little guardians are. But, and this is a big but, like any hero, they have their limits. They can't just fight off an infinite attack. And that limit has a name. It's called buffer capacity. Think of it this way. It's basically how much acid or base that chemical sponge can soak up before it's totally saturated. Once it's overwhelmed, the pH will start to change, and fast. And this chart shows it perfectly. Every buffer has a sweet spot, a specific pH where it's at its most powerful. See that peak right there in the middle of the curve? That's it. That's where it's strongest. Now, as the pH moves away from that sweet spot, in either direction, its power, its buffer capacity, starts to drop off. It just gets weaker and weaker. So the big takeaway here is that even though these buffers are amazing protectors, they're not invincible. Their power isn't unlimited. If you hit them with a big enough chemical shock, you can overwhelm them,
and that can push the whole system right past its breaking point.
And that brings us right back to where we started, with a really stark reminder of what the stakes are. Because when the pH of your blood falls below 7.0 or goes above 7.8, life is in danger. It's that simple. When the buffers in our blood get overwhelmed, we get pushed right outside that tiny, fragile window of life.
So, buffers. They're just a perfect example of one of these elegant, invisible systems that literally makes life possible. They're the constant, unsung guardians of our chemical stability. And that kind of leaves you with a final thought, doesn't it? What other unseen balancing acts are going on inside of you, right this second, just to keep everything running perfectly?